إذا الأمجاد قد عظمت فللأمجاد بانيها، ومن يسعى إلى العليا سيدركها بما فيها، ويبني مجده جدلا فروح الفذ يعليها، ليصبح همة تروي عن العليا.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another exciting episode of K-Way Mathematics. I'm your host and presenter, Muhammad Kota, doing the mathematics preparation for the grade 11s and 12s for 2015. Now, for those of you who have just joined the show, to just give you a brief background as to what we've been doing, we've been covering paper 1 and paper 2 for the CAP syllabus for grade 12s. In preparation for the 2015 examination. And I'd just like to thank all our callers who phoned in on our live show on last week Thursday, and we had a bumper episode where callers from all over the country phoned in and said, solve these problems. We took your comments, we took your suggestions. We'd also like to thank you, the viewers, for emailing us and letting us know exactly how you felt about the show and what would you like to see more on the show. Okay, so boys and girls, let's get started with our program. Today's episode, it will be dealing with sequences and series. Now, I will be dealing today with grade 11 and 12. I'll cut away. I'll start with the grade 11 content. I'll then cut away. I'll break away and then say, right, grade 11s, this is where you put your pens and papers, books away. And let's now get started with the grade 12 content. So, boys and girls, let's not waste any time. Get out your scientific calculators, get out your examination pads and your pens, and let's start with today's topic. Today is sequences and series. Now, under sequences and series, we're first going to do the quadratic number pattern. Before we actually get into the topic on sequences and series, let's start with the quadratic number pattern. So, put the heading, the quadratic number pattern. And we all know that we are talking here about second difference. Second difference. Now this is grade 11 and 12. So I'm just going to make a note here on the side. Grade 11 and 12. Okay. We know from our grade 11 concept you get the first difference, which is linear. Then you get the geometric, and then you get the quadratic. But we're starting with the quadratic. Then we'll move into sequences. And that's where the grade 11s will stop, and then we'll move into series and then go into sigma notation. So let's start with the quadratic number pattern. The question that will appear in the exam is that you are given a pattern, a number pattern, 2, 12, 28, 50. Right? Question number 1. Right? In fact, let's do this. Let's put the questions here on the side and we'll do the calculations on the right. So the question that will appear is extend the pattern by 2 terms. Extend the pattern by 2 terms. If the pattern continues in a consistent manner. Number 2, find Tn, the general expression. Now you know this is the typical style of questions that would appear based on a number pattern. And then say find the 20th term. Now the first question here would be worth probably 3 marks. Find Tn, the general expression, worth 5 marks. So you got 3 and 5, that's 8. Find the 20th term, another 3 marks. So total marks, 11 marks. Okay? Now boys and girls, firstly, we've got to identify what's given. Are there unknowns given in the pattern, or is it are we given exact values? In this case here, we're given exact values: 2, 12, 28, and 50. They want us to continue the pattern if it behaves in the same manner. Now, boys and girls, with all these topics, just to bring you to put you into the picture, we are now busy covering all these topics, showing you the processes and procedures on how it's done. Obviously, these are not the only types of questions that you are going to see. And there's a variety of questions and techniques available. Now, if you need further and if you need more in-depth explanation about certain topics, please, boys and girls, we do have our DVD sets here. Our DVD sets will cover all 12, the entire grade 11 and 12 syllabus comprehensively with every humanly possible type of question with a workbook. So boys and girls, we are running this this ITV special here at 1450 for the 12th set, and you can contact us on the email address that will appear on your screen at kwaymath@gmail.com, kwaymath@gmail.com. So boys and girls and the viewers, if you feel like you still need more intensive revision and explanation concerning every single topic in mathematics, this is only a taste. This year shows you how certain processes are done so you can get working with it. Obviously, these are not the only humanly possible type of questions that you could get. The balance of them are all on the set. So phone in, place your orders so that we can get the set out to you so that you, the viewer, can be prepared for the exam. Now remember, the set is not only for the learner, it's for teachers who would like to up their skill. If you are a grade 10 teacher and you would like to know your grade 11 content, get the set so that you can see different strategies and different techniques that are used. So it's for parents, it's for learners, as well as for teachers who would like to up their skill. Right, let's get back to the quadratic number pattern. We've got the quadratic number pattern 2, 12, 28, 50. To extend it by 2 terms, we go from 2 to get to 12, we said plus 10. We say plus 10 because 2 plus 10 will give me 12. 12 to get to 28, 16. 28 to get to 50, it's 22. So it's 12 minus 2 to give me 10. 28 minus 12 to give me 16. 50 minus 28 to give me 22. So you can see there's no first difference. The first difference is all different. 10, 16, 22, the values are all different. Let's now go on to our second line. 16 minus 10 is 6. 22 minus 16 is 6. So we can see that it's got a common second difference. It's got a common second difference. That's why it is quadratic. Quadratic number pattern, we put a square. We put a square sign there. Why? Because it's got a common second difference. And we know that the general expression for a quadratic number pattern, let's put it here on the top, Tn is equal to an squared plus bn plus c. Remember, we need to find a, b, and c. It's like a quadratic equation where you had ax squared plus bx plus c or ax squared plus px plus q. This is exactly the same, an squared plus bn plus c. We're solving for a, we're solving for b, and we're solving for c. Okay, back to our problem. So there we go. We've got our 12 minus 2 to give me 10, 28 minus 12 to give me 16, 50 minus 28 to give me 22. 16 minus 10 to give me 6, 22 minus 16 to give me 6. So obviously, we now need to extend the pattern by 2 terms. So you start from the bottom up. So let's go. 22 plus 6. Remember, plus 6 plus 6. 22 plus 6, 28. 50 plus 28, 78. There we go. We've extended by 1 more term. We want to extend by 1 more term. So 28 plus 6, 34. 78 plus 34, 112. So there we go. We've answered the first question, boys and girls. We've answered the first question. Extend the pattern by 2 terms. There we go, 78 and 112. The answer to question number 1, you will just write 78 and 112. No need to show the diagram, but very imperative that you do the diagram. You've got to complete it. You've got to complete it, and once you've completed it, you just put your 2 final solutions there, which is 78 and 112, and boys and girls, you'll get your first 3 marks. Find Tn, the general expression. So now we're answering question number 2. Now, whenever we have second difference, whenever we have a common second difference, we've got 3 formula. Right? There's many ways in which it can be done. Sometimes your teachers will show you by hectic simultaneous equations where it can be over a page of calculation. Okay? I'm going to show you the shortest possible way in which you can solve for A, B, and C. Now, there are 3 formulas for solving for A, B, and C. We start off at the bottom. 2A is equal to your second difference. On your second line, you've got 3A plus B equals your first difference. And on your first line, you're going to say A plus B plus C is equal to your first term. So, don't ask me where you get these formulas from. Just learn them. 2A, 3A plus B, A plus B plus C. 2A, 3A plus B, A plus B plus C. So, 2A is equal to your second difference. 3A plus B is equal to your first difference. A plus B plus C is equal to your first term. And start solving from the bottom up. So let's start. Remember, we said from the bottom up. So here's your first equation. 2A is equal to 6. 2A is equal to 6. So A is equal to 6 over 2 is 3. Now we go to our second line. 3a plus b is equal to 10. We've got a, 3. So it's 3 into 3 plus b is equal to 10. 9 plus b is equal to 10. b is equal to 10 minus 9, which is 1. We now go on to our first line, which is a plus b plus c. We got a plus b plus c is equal to 2. We've got a, 3. We've got b, c, 1 plus c is equal to 2. c is equal to 2 minus 4 is minus 2. There we go, boys and girls. We're now going to cut for an ad break. But before we go there, what I'd like you to do, I'd like you to copy and paste this model down. So now we've got Tn is equal to an squared plus bn plus c, which is equal to, we've got a 3n squared plus bn plus 1n minus 2. That's your c value. And there we go. That's your general expression. Boys and girls, we're going to cut for an ad break. During the after the ad break, we're going to come back. I want you to continue, and I want you to go and find the 20th term. Answer question number 3, and I'll give you the solution as soon as we get back.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome to the K-Way Math Show. Welcome back from the ad break. Just to recap quickly where we left off before we went for the break. We started off here with the quadratic number pattern. We said the original question that was given before the break was 2, 12, 28, 50. That's all that was given. 2, 12, 28, 50. That was the sequence that was given. And the first question was extend the pattern by 2 terms. Find Tn, the general expression, and find the 20th term. So we started here on the top, 2, 12, 28, 50. From 2 to get to 12 was 10. 12 to 28 was 16. 28 to 50 was 22. 10 to 16 was 6. 16 to 22 was 6. We continue the pattern going up. So 22 plus 6 is 28. 50 plus 28 is 78. 28 plus 6 is 34. 78 plus 34 is 112. So there we go. We've extended by 2 terms, 78 and 112. The next question. Find Tn, the general expression. We started off, I said there are 3 formula. 2a is equal to 3a plus b plus c. Start from the bottom up. So 2a is equal to 6. A is equal to 6 over 2 is 3. Second line, 3a plus b is equal to 10. There we go. 3 times 3 is 9 plus b is equal to 10. 9 plus b, b is equal to 1. A plus b plus c is equal to 2. There we go. We plug in a, we plug in b, we solve for c. We go into our general formula. Tn is equal to an squared plus bn plus c. There we go. An squared plus bn plus c. An squared, 3n squared plus bn plus 1n plus c minus 2. And there we go, boys and girls. That's where we left off before the break. Then I told you to find the 20th term. The question said find the 20th term. So what do we want? We want T20. So we got our final equation here. Tn is equal to 3n squared plus n minus 2. So T20 is equal to 3 into, for every n we're going to put 20. We want to find the 20th term in the sequence. So 3 into 20 squared plus 20 minus 2. This is equal to 20 squared is 400 times 3 is 1200 plus 20 minus 2, which is equal to 1218. And there we go, boys and girls. The 20th term in this sequence, if that sequence had to continue in the same pattern, term number 20, the value of that term would be 1218. Okay, now I'm going to show you another. This is method 1 to get your solution. I'm now going to show you an alternate method. So in your exam, you can do either one of the two. Many of you have never seen the next method that I'm about to show you. Okay, so enjoy it. Why? Because you now got 2 different methods. So what you're going to do in the exam is that you can use method 1 and then use method 2 to check. Or start off using method 2 and then use method 1 to check. Sorry, excuse me. Whichever way, both of them must give you the same solution. So now I'm telling you, let's not use this method. This is one method of getting your general formula. How about trying another formula? Now I'm going to give you one. Here we've got 3 separate formulas. What happens if I give you one formula and we see whether we get exactly the same solution? Now many of you are going to say, whoa, I've never seen this before. Well, you can use it. It's government approved. You are allowed to use it. It's even part of your national matric marking memorandum. So if any of you go through it and check all the different strategies, this is one of the strategies that is also applied. So to get T and the general expression, to get the same answer, to get the same result as this, let's try a different method. Watch this. I tell you now, use Tn is equal to term 1 T1 plus n minus 1 times your first difference plus n minus 1 n minus 2 plus n minus 1 n minus 2 over 2 times your second difference. Now it might seem like a mouthful. That formula might seem like a mouthful, but you know all these formulas, once you start applying it once or twice, you'll know that these formulas will stick. So just remember this. Tn is equal to term 1 T1 plus n minus 1 times your first difference plus n minus 1 n minus 2 over 2 times your second difference. Now all we do is we just substitute our values in here, expand it, and we're going to get exactly the same answer as we've done with the 3 different formulas. So let's check it out. You choose which one you'd like to use in the exam. So let's start. Term 1. What's term 1? 2 plus n minus 1. What's your first difference? 10 plus n minus 1 n minus 2. That will give me, if I FOIL this, if I multiply this out, this will be n squared. Minus 2n minus 1n is minus 3n plus 2 over 2 times your second difference. What's your second difference? 6. Now, collect your like terms. 2 plus 10 times n, 10n, minus 10 plus 2 goes into 2 once, 2 goes into 6 3 times. 3 times n squared, 3n squared minus 3 times, remember you're multiplying this 3 by all 3. So 3 times minus 3n minus 9n plus 6. This is equal to 3n squared, there we go, plus 10n minus 9n plus 1n, 2 minus 10, negative 8, negative 8 plus 6, negative 2. Tn is equal to that. There we go. Exactly the same solution, using 2 different methods. Absolutely different formula. The first one we did, we said 2a, 3a plus b plus c. In this one we said Tn is equal to term 1 T1 plus n minus 1 times your first difference plus n minus 1 n minus 2 over 2 times your second difference. Substituted our values, removed the brackets, collected our like terms, and we got exactly the same result. Okay, so there we go. That is the quadratic number pattern. Now let's do the reverse, and many of you may ask, what happens if they tell you it's a quadratic number pattern? You need to do the reverse, and you need to get back the values that's in there. So let's show you what that scenario will look like. Remember, we always tell you in mathematics, we need to do the forward and we need to do the reverse. So this was the forward. They gave us the pattern, we needed to find the equation. Now they tell us it's quadratic, and they're going to put x and y there, and they're going to say solve for x and y for 10 marks. Here you're going to be using simultaneous equations. So stay tuned and stay focused. This is grade 11 and 12. They love asking this question. So let's get started. Let's see what the pattern looks like now. Okay, we're going to be using exactly the same pattern. So we already know what result we need to get. Let's start. We're now going to go to x. Remember, we had 2, 12, 28, 50, 78, 112. Right. We already know, because this is exactly the same as our previous pattern. We already know what x and y is. X is 12, y is 50. We need to prove it. Now they tell you, you're given this. And it is, they say, this is a quadratic number pattern with a second difference. Quadratic number pattern. Solve for x and y. 8 marks, guys. 8 marks. Okay, so now we're in a different ball game altogether. Now, the first thing you need to understand is that where do we begin? We need to complete the pattern. So how did we get? Remember something. Here's our model. Just think about this. 2, 12, 28, 50. Right? How did we get this value here? We said 12 minus 2 to give me 10. So obviously, what are we going to do? To get this value here, what are we going to say? X minus 2. What are we going to say here? 28 minus x. To get my first differences. What am I going to get here? I'm going to get y minus 28. Here I'm going to get 78 minus y. Here I'm going to get 112 minus 78 is 34. Okay, That's my first difference. So remember, from our original pattern, this was 10, this was 16, that was 22. How did I get my second difference? I took this term, my second term of my first difference, minus my first difference. So 16 minus 10, and that gave me my 6. So obviously, to get this value here, it's going to be 28 minus x minus x minus 2. And that's going to give me what this first term is here. So what do we have? We've got 28 minus x plus 2, which is equal to 28 plus 2 is 30 minus 2x. And there we go. That is what my second difference is. In terms of x, 30 minus 2x. Taken from where? Taken from the same pattern as we had here. Okay. How will we get our term here? We're now going to say y minus 28. There we go. Y minus 28 minus 28 minus x. Minus 28 minus x. So this is going to equal to y minus 28 plus x, which is going to equal to x plus y minus 28 minus 28 minus 56. And there we go. That is our next equation. Now what I'd like you to do, boys and girls, before we cut for an ad break, I'd like you to continue the pattern. Now that we've got our first term here, we've got a second difference here, we've got a second difference. I'd like you to find out what is that on your own, and I'd like you to find out what is that on your own. Right, so you got 3 minutes during the ad break. When we get back, we'll continue and we'll be solving for x and y. So continue with the pattern, boys and girls. We're cutting for an ad break. I'll see you in 3 minutes time.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, brothers and sisters, welcome back to the K-Way Math Show. With me, your host, Mohammed Kota, from the K-Way Mathematics Institute here in Johannesburg. Before we cut for an ad break, we were busy with the quadratic number pattern. So we gave you 2x, 28y, 78, 112. We told you it's a quadratic number pattern. Solve for x and y. And we said this is a critical component for grade 11s and 12s. Okay, so where did we stop? We then said, how did we get our values? We said x minus 2 to give me the first difference here. We said 28 minus x to give me the first difference there, 9, y minus 28, 78 minus y, 112 minus 78. We then took 28 minus x minus, we took this value minus that value to give you 30 minus 2x. We then took that minus that to give me x plus y. I told you during the break, please continue the pattern and let's check how well you've done. Let's see what you've got. You've got 78 minus y, there we go, minus y. I'm now not going to put, okay, let's just put the brackets for minus y minus 28. So what do we have? We've got, this is equal to 78 minus y plus 28, which is equal to 78 plus 28, 1790, 106 minus 2y. Let's now go on to the last one here where we've got 34 minus 78 minus y, which is equal to 34 minus 78, negative, that we got plus y, which is equal to y minus 44. Yes or no? 30, 40, 78. There we go, y minus 44. Now, we've got a host of equations at the bottom. Why are we getting this? We want to get our second differences in terms of x and y. What do we know about our second differences? They are equal. 6 is equal to 6 is equal to 6. So all these are all equations and they are all equal to each other. So if they are equal to each other, hence we can formulate equations, and once we got equations, we can then obviously solve for x and y. So what do we have? We've got an equation here in terms of x, we've got an equation here in terms of x and y. So let's call that one equation number 1. We've got another set of equations, a pair of equations here at the end, and this one is only in terms of y, and we're going to call that one equation number 2. Now common sense will tell you, you cannot start with equation number 1 because you've got x's and y's. So we're going to start with equation number 2. So let's start with equation number 2 and let's solve for y. So equation number 2 looks like this: 106 minus 2y is equal to y minus 44. Let's solve for y. Minus 2y minus y is minus 3y is equal to minus 44 minus 106. Remember, plus 106 goes over as minus 106. So minus 3y is equal to minus 44 minus 106 is minus 150. Divide by negative 3. Divide by negative 3. What do we get? Y is equal to 50. Negative divided by negative is a positive. 150 divided by 3 is 50. Isn't y 50? Yes. Do we think we're right? No. We know we're right. Okay, we've just done a check, we've gone right back, we've solved for y, we looked at what our original is, we know y is 50. So there we go, y is 50. We now need to solve for x. We've solved for y, we now need to solve for x. So now let's look at what equation number 1 looks like. Equation number 1 looks like this, 30 minus 2x is equal to x plus y minus 56. I hope you guys are paying attention, and I hope you're enjoying the show and following the sequence. Remember, mathematics is about structure. What our guest in studio told us on Thursday, in Thursday's episode, that structure is one of the most critical components of mathematics. So get your structure right. Follow the structure, follow the order. So we've got 30 minus 2x is equal to x plus y minus 56. So 30 minus 2x is equal to x plus 50 minus 56. Right? So what do we have? Minus 2x minus x minus 3x is equal to, we got 50 minus 56 is minus 6 minus 30. So now we've got minus 3x is equal to minus 36. X is equal to minus 36 over minus 3. X is equal to 12. X is equal to 12. Is x equal to 12, boys and girls? Yes. From our original pattern, we knew x was 12, y was 50. That was the calculation on how we got to it. Boys and girls, this is worth 8 to 10 marks. Please make sure that you understand this. Please make sure you replay this. You do it over and over and over. What's important now is that you understand how it's done. Mastering it is going to take a lot of practice. And included on with this here, if you need additional practice and you need additional explanation, please, boys and girls, contact us, kwaymath@gmail.com. Place the order for our DVDs. It's the entire set, guys. It's the entire grade 11 and 12 set over 12 discs. $14.50 gets you the set. Place an order, 7 to 10 days for delivery. We ship across the world. Please make sure you place the order and get the set. Get a copy of the set. If you're in grade 11, you'll be using the set right through until the end of grade 12. When you get to the end of grade 12, you'll take the set and sell it to somebody else. We want, what our aim here at ITV is, we want to make sure that this set gets into every home. As long as you are a grade 11 and 12 or 12, 10, 11 or 12 mathematics, pure math learner, this set should be compulsory on your bookshelf. Okay, remember, within the next 2 or 3 years, maths literacy is going to be completely phased out. Mathematics literacy is going to be completely phased out, and you're going to have the whole country that needs to do pure math. How are you going to do mathematics? Here's the teacher in the box, in your home. Avoid tuition, avoid extra support, whatever. The DVD set is what's going to get you your distinction in mathematics. K-Way Math is the way to go. It's the way to go, boys and girls. Let's now go on to our next component of sequences and series. Okay, that was the quadratic number pattern. We're now going into full-blown sequences and series. The initial part of sequences will still be for grade 11, but the majority, the bulk of this content is grade 12 work. Okay, so let's start with sequences. Okay, this is for grade 11s and 12s. Right, what is a sequence? A sequence is a number pattern separated by a semicolon. That's how you will identify it in the exam. Now, I'm going to draw up a mind map here on the screen. I want you to learn this mind map. This here is going to summarize all your formula, because many of you don't know which formula to use where. So this mind map is going to classify it for you. It's going to clarify it for you so that you know which formula to use where. So in sequences, we all know you get arithmetic. And the arithmetic, another word for it is linear. And then you get geometric. Now we know that the arithmetic or the linear has got a common difference. A common first difference. And that is what we would regard as arithmetic. Then you've got geometric, which has got a common ratio. Now, just to give you an example of what each of them would look like. If you look at arithmetic or linear, you're given a pattern 2, 5, 8, 11, going on to infinity. So there we know this is arithmetic, it's linear. Why? It's got a common difference. What's your common difference? From 2 to get to 5, plus 3. From 5 to get to 8, plus 3. 8 to get to 11, plus 3. So it's your term, your first term, plus your common difference to give you your second, to get your second term. Second term plus your common difference to get your third. Third term plus your common difference to get your fourth. And it will continue that way in that pattern to infinity. So there we go. That's your arithmetic or linear pattern with your first difference. Now we got a common ratio. So if I had 1, 2, 4, 8, 16 going on to infinity. Now here you cannot say 1 plus 1 yes, 1 plus 1 gives you 2. But 2 plus 1 would have given you 3 if it was arithmetic. So it's not. It's 1 times 2 to give you 2. 2 times 2 to give you 4. 4 times 2 to give you 8. So you can see it's got a common ratio. You multiply. It's your first term. Whereas in your arithmetic, it's your first term plus your common difference to give you your second term. Your geometric, it's your first term times your common ratio to give you your second term. Times the same ratio. So it's 1 times 2 to give me 2, 2 times 2 to give me 4, 4 times 2 to give me 8, 8 times 2 to give me 16, and you can continue the pattern towards infinity. So now that we've identified what they look like, what are the formula that are used in order to determine, to extend by 2 terms, to find Tn, the general expression, and then say to find the 20th term or the 50th term. So we know that in arithmetic, Tn is equal to, your first formula that you need to know for arithmetic, Tn is equal to A plus n minus 1 times D. A being your first term, A being your first term, D being your common difference. Okay, so so Tn is equal to A plus n minus 1 times D. And that is your general formula for finding the equation of an arithmetic or linear pattern. For geometric, Tn, obviously it cannot be the same formula. It's AR to the power n minus 1. Remember, n is a term, Tn is the value of that term. So say they tell you the 50th term. So that means n would be 50. Tn would be the value of that 50th term in the sequence. So here are your two formulas. Remember, sequences now broken up into 2 parts, arithmetic and geometric. Arithmetic, Tn is equal to A plus n minus 1 times D, and geometric, Tn is equal to AR to the power n minus 1. So boys and girls, take this down. What's also important for arithmetic is that there's a formula for calculating the common difference. And the formula for calculating the common difference is T3 minus T2. T3 minus T2 is equal to T2 minus T1. And for geometric, T3, to calculate your common ratio, or R, T3 over T2 is equal to T2 divided by T1. Now boys and girls, we're cutting for an ad break. What I'd like you to do now, and we're then going to go into the last segment of today's episode. So take all this down. Please make sure that you understand it. And when we get back from the ad break, we will go into some application of arithmetic and geometric sequences and exam style questions that you could possibly see in your final exams. Stay tuned.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها. Boys and girls, welcome back to the K-Way Math Show. Before we cut for the ad break, this is what we've done. We started with sequences and series. We know I've given you a mind map. I want you to remember this mind map. I want you to brand it on your brain. That sequences are broken up into 2 parts. Arithmetic, there we go, arithmetic and geometric. Arithmetic, the general formula, Tn is equal to A plus n minus 1 times D. And it's got a common difference. And the formula for your common difference is T3 minus T2 is equal to T2 minus T1. Then you've got your geometric. Your geometric Tn is equal to AR to the power n minus 1. And it's got a common ratio. Your first term times your common ratio gives you your second term. Second term times your common ratio gives you your third term.
And the formula for that is T3 over T2 is equal to T2 divided by T1. Something that I want you to also remember in this. So all these concepts, very, very important for you to remember, these formulas. And then you've got T10 in arithmetic. I want you to remember is known as A plus 9D. Right? You just subtract 1 from the number of terms. So T10, A plus 9D. T20, A plus 19D, to convert it into proper language. Term 50, A plus 49D. Term 100, A plus 99D. Let's now go into geometric. T10 here would be known as AR to the power 10 minus 1, which would be known as AR to the power 9. So if they told you the 10th term is 50, so you'll say AR to the power 9 is equal to 50. Convert it into its proper language. Very important concept. You'll see how this concept will unfold when we start doing application. So please make sure you have this down. Okay. Let's now go into series. So today, in this last segment, for today's episode, we're now just going to focus on the formula. I'm now going to show you all the formula. In our next episode, you please stay tuned. Remember, we are following a series of episodes. So if you have missed one, very difficult, you better phone into the station, try and find out what was played, or find out when are the repeats of the shows. So please make sure that you follow this, or go to your friend, find out what happened in the previous show, because these are all following sequences. We started last week. We're already probably on show 4, 5. We're on show 5 already, going through all the different systems in mathematics. So please remember, it is a sequence of episodes. So let's start here. Series. Okay? Now, what is a series? Series means you sum. Now, this is purely grade 12 only. Guys, this is grade 12 only. Grade 11s, you can log off. But it would be good for you. Just sit and watch it. Enjoy the show. So we started here. We start with series. Series is separated. So instead of you having 2, 5, 8, you got 2 plus 5 plus 8. You are summing the sequence. So when you sum a sequence, it's called a series. Okay? Normally you'd have a sequence when you're finding the total. What is the total value of that sequence? That is called a series. So 2, 5, 8, so you can be separated by a plus or minus. How do we identify a series in an exam question? You'll see a plus or a minus sign separating the terms, like how we had 2 plus 5 plus 8, just to show you. Or you'll see the word, they will use the word sum in the problem, so it means, or they might use the word a total of. Then you know that it is a series question and not a sequence question. Now you might be asking yourself, so then what's the difference? The difference is huge. The one you are finding a term, or what is the position of a term in a sequence. In series, you are finding its total, and it uses totally, absolutely different formula. And what is the mind map for this? Okay, for series, series is also broken up into 2 parts. Series is broken up into 2 parts, and many of you are already screaming, yeah. Series, we know it's broken up into 2 parts, arithmetic and geometric. Wrong. Series is not broken up into arithmetic and geometric. Series is broken up into finite, meaning one that ends, and infinite or infinite, meaning one that doesn't end, one that goes on, ... going on to infinity. Okay? So, sequence. Now, pay attention. Sequence was broken up into arithmetic and geometric. Series is broken up into finite and infinite. Now, finite is broken up into 2 parts, into arithmetic and geometric. Finite, infinite, boys and girls, infinite is also broken up into 2 parts, but not arithmetic and geometric. Infinite is only geometric. Why? We're finding a sum. If I gave you an example, 2, 4, 6, 8, 10, you know that's arithmetic. 2, 4, 6, 8, 10, 12, 14, 16. It's going on to infinity. Find me the sum. Can you do it? No, you can't. It's just going on. How are you going to find the total of that value? You cannot do it. But for an infinite, for geometric, the sum will either move towards a number or it will move away from a number. So, infinite is only geometric, but that geometric is broken up into 2 parts. This geometric is broken up into convergent and I know that, and many of you are screaming out already, and divergent. Now, convergent, how do we know that something convergent means that as you add more and more terms, the sum will move towards a number. Divergent means as we add more and more terms, the sum will move away from a number. How do we identify between convergent and divergent? Just calculate R. Just calculate R. If R is a fraction, it's convergent. Once you calculate your common ratio and you find out that your common ratio is a fraction, automatically it's a no-brainer. It's convergent. If R is a whole number, it's divergent. There must be a formula for this. R must be less than 1 but greater than -1 for it to be convergent. There we go. It's a fraction. Any number between 1 and -1 is a fraction. And what is the formula for divergent? R greater than 1. Okay, so there we go. So series, let's quickly go through it. Series broken up into two parts. Finite and infinite. Finite broken up into two parts, arithmetic and geometric. Infinite, only geometric, broken up into two parts, convergent and divergent. Okay, that's it for now. Let's now go into the formula. For arithmetic finite, Sn, now we don't say Tn, we're finding the sum. Sn is equal to n over 2 into a plus l if last term is given. That's L, last term given. If the last term is given, you use this formula. If the last term not given, Sn equals n over 2 into 2a plus 2a plus, let's write the a properly, 2a plus n minus 1 times d. There we go. That's for arithmetic. For geometric finite, Sn is equal to a into r to the power n minus 1 over r minus 1 if r is greater than 1, meaning if r is a whole number. Or Sn is equal to a into 1 minus r to the power n over 1 minus r if r is less than 1 but greater than -1, meaning if r is a fraction. Okay, so for arithmetic, Sn equals n over 2 into a plus l if last term is given, or Sn equals n over 2 into 2a plus n minus 1 times d if last term is not given. For geometric, Sn is equal to a into r to the power n minus 1 over r minus 1 if r is a whole number, right, if r is greater than 1, or Sn equals a into 1 minus r to the power n over 1 minus r if r is a fraction, meaning if r is less than 1 but greater than -1. Okay, whole lot of mouthful of numbers. Convergent, right, how do we know if r is a fraction? S to infinity, because that's what we're trying to calculate, s to infinity is equal to a over 1 minus r, very simple formula, first term over 1 minus your common ratio, or if it's divergent, s to infinity is equal to a over r minus 1. And there we go, boys and girls, that is your complete mind map. So I gave you 2 mind maps today. The first mind map, in fact we've done 3, let's quickly do a recap. We started with the quadratic number pattern. The quadratic number pattern, the second difference, we had 3 formulas, 2a, 3a plus b plus c. Then I gave you the alternate method where I gave you 1 formula. So if you go back into today's show, you'll find, or go back into your notes, you'll see Tn is equal to term 1 plus n minus 1 times your first difference plus n minus 1, n minus 2 over 2 times your second difference. Those were 2 alternate methods in order to get the same result. Okay, that was for second difference. Then we went into sequences. We said sequences, now very important, and I'm going to keep on drumming this into your head so that you understand that sequences broken up into 2 parts, right? Arithmetic and geometric. For arithmetic, Tn is equal to a plus n minus 1 times d, and it had a common difference, T3 minus T2 equals T2 minus T1. Then you had geometric, Tn is equal to a r to the power n minus 1, it had a common ratio, and the formula for calculating common ratio T3 over T2 is equal to T3 over T2 is equal to T2 over T1. Then we gave you series, just to quickly recap before we close the show, series broken up into 2 parts, finite and infinite. Finite, arithmetic and geometric, they are your formulas. Infinite is only geometric, it's got 2 formulas, it's got 2 components, convergent and divergent. Boys and girls, I hope you enjoyed today's show. Today's show only focused now on the formula. Stay tuned for tomorrow's episode. Please tune in again, same time, same place, 3:30 to 4:30 here on channel 347 ITV for the K-Way Match Show. We are now going to be doing the application, exam style question, 8-mark and 10-mark questions in tomorrow's show. Stay tuned, and for those of you who'd still like to place the orders for our DVD sets, the DVD sets are available at $14.50. Place your orders via kwaymath@gmail.com. Get the set and start working.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا مغاريها.